For years, Proxima B was considered one of the most promising worlds beyond our solar system, a rocky planet orbiting the nearest star to the Sun. Close enough that, in cosmic terms, it almost feels like our next-door neighbor. Scientists hoped it might even be another Earth. But the newest observations coming from the James Webb Space Telescope are forcing researchers to reconsider that hope. Because what Webb is beginning to reveal about Proxima B doesn't look familiar. In fact, it looks strange. Strange enough that some astronomers now think this nearby world may be far more extreme and far more mysterious than anyone expected. And we may have only just started to see it. Welcome to Simulation Hypothesis. This is where we question the grand promises of space and examine what the physics actually allows. No hype, no fantasy, just the reality hidden behind the beauty. If you're new here, subscribe and stay with us, because sometimes the most fascinating discoveries in astronomy are also the ones that force us to rethink what we thought we understood about nearby worlds. In cosmic terms, Proxima Centauri is right next door. It lies about 4.24 light-years away from Earth, closer to us than any other star beyond the Sun. If the entire solar system were shrunk to the size of a house, Proxima Centauri would be like the next house down the street. But unlike our Sun, Proxima Centauri is not a bright yellow star. It is a red dwarf, small, dim, and extremely active. Red dwarfs are the most common stars in the Milky Way. In fact, astronomers estimate that nearly 70% of all stars in our galaxy belong to this category. They burn their fuel slowly and can live for trillions of years. At first glance, they seem like ideal hosts for planets. But red dwarfs also have a darker side. They are volatile. In 2016, astronomers made an announcement that instantly captured global attention. Using the HARP spectrograph at the European Southern Observatory in Chile, researchers detected a small wobble in Proxima Centauri's motion. This wobble revealed the presence of a planet. They named it Proxima Centauri B, or simply Proxima B. The discovery was historic for one simple reason. Proxima B sits inside the habitable zone of its star, the region where temperatures could allow liquid water to exist on a planet's surface. The planet itself appeared promising. Its mass is estimated to be about 1.3 times that of Earth, making it very likely a rocky world rather than a gas giant. Its orbit is extremely tight, circling its star once every 11.2 days. At first, that short orbit seemed alarming. But Proxima Centauri is so faint that a planet must orbit very close in order to receive enough warmth to remain temperate. In theory, the conditions might be similar to Earth's. For the first time, humanity had discovered an Earth-sized planet in the habitable zone of the nearest star. It was difficult not to imagine oceans, clouds, and perhaps even life. But almost immediately, scientists began noticing problems. The first issue was distance. Proxima B orbits its star at only 0.048 astronomical units, about 20 times closer than Earth is to the Sun. At that distance, tidal forces become extremely strong. Most astronomers believe Proxima B is tidally locked, meaning the same side of the planet always faces its star. One hemisphere would live in permanent daylight. The other would remain in eternal darkness. That alone would create extreme climate patterns. But the star itself is the bigger concern. Proxima Centauri is a flare star. This means it frequently releases powerful bursts of radiation. In 2019, astronomers observed one of the largest flares ever recorded from the star. It increased Proxima's brightness by more than 14,000 times for a brief period. For a planet orbiting so close, that kind of flare is devastating. These eruptions blast space with X-rays, ultraviolet radiation, and charged particles. Over time, this radiation can strip away a planet's atmosphere. Without an atmosphere, liquid water cannot survive on the surface. This is why many astronomers now suspect that planets around red dwarfs may struggle to remain habitable. Their stars simply behave too violently. But until recently, these ideas were mostly theoretical. We did not have direct observations of the planet itself. That is where the James Webb Space Telescope enters the story. When Webb launched in December 2021, it became the most powerful space telescope ever built. Unlike the Hubble Space Telescope, which mainly observes visible light, Webb is optimized for infrared astronomy. This allows it to detect faint heat signatures and analyze the chemical composition of distant atmospheres. In other words, Webb can do something astronomers have dreamed about for decades. It can study the atmospheres of planets orbiting other stars, even planets hundreds of trillions of kilometers away. For systems like Proxima Centauri, this capability is revolutionary. Because although Proxima B is incredibly close in astronomical terms, observing it directly is extremely difficult. The star itself is thousands of times brighter than the planet. Trying to see Proxima B is like trying to spot a firefly next to a floodlight. But Webb's instruments are sensitive enough to detect subtle signals that earlier telescopes could never see. And those signals are starting to reveal something strange. One of the first surprises came from observations of the Proxima Centauri system's dust environment. Webb and other observatories have detected evidence of multiple dust belts surrounding the star, similar to the asteroid belt and Kuiper belt in our own solar system. But these belts appear far more chaotic. Gravitational interactions between objects in the system may be far more intense than originally expected. This suggests that Proxima B may have experienced a turbulent history of impacts and orbital disturbances. In planetary systems, chaotic environments can have profound consequences. Frequent impacts can reshape surfaces, alter atmospheres, and even sterilize entire planets. Earth itself experienced such a period roughly 4 billion years ago, known as the Late Heavy Bombardment. But Earth eventually stabilized. Whether Proxima B had the same opportunity is unclear. Then came another puzzling observation. Some models suggest that if Proxima B ever had an atmosphere, it may have been gradually stripped away by stellar winds. Red dwarf stars can produce stellar winds hundreds of times stronger than the solar wind emitted by our sun. Over millions of years, that wind acts like a sandblaster on planetary atmospheres. If Proxima B lacked a strong magnetic field to protect itself, the atmosphere could have been slowly eroded into space. Without atmospheric protection, the planet's surface would be exposed directly to radiation from its star. Any oceans that once existed could evaporate or freeze. And yet, some scientists are not ready to abandon hope. Because planets can be surprisingly resilient, there is another possibility. Some researchers believe Proxima B might possess an extremely thick atmosphere, perhaps rich in carbon dioxide or other greenhouse gases. Such an atmosphere could trap heat and help distribute energy between the permanently lit side and the dark side of the planet. Others suggest that oceans beneath a thick cloud layer could still survive. In fact, some climate models indicate that even tidally locked planets might maintain stable climates under the right conditions. But this is where the latest observations are beginning to complicate the picture. Because the signals Webb is detecting do not always match what scientists expected to see from an Earth-like world. Some of the thermal patterns appear unusual. Some atmospheric models do not behave as predicted. And the deeper astronomers look, the more they realize something important. Proxima B may not resemble Earth at all. This realization is forcing researchers to rethink the original optimism surrounding the planet. For years, Proxima B represented humanity's closest chance of discovering another habitable world. It was the destination people imagined when discussing future interstellar missions. Projects like Breakthrough Starshot even proposed sending tiny laser-propelled probes toward the system at a fraction of the speed of light. At that speed, a probe could reach Proxima Centauri in about 20 years. But the question scientists are now asking is simple. If we ever get there, what exactly will we find? Because the latest evidence suggests that Proxima B may be far stranger than anyone imagined. And the closer we look, the more this nearby planet begins to resemble something completely unfamiliar. By the time Proxima B was discovered in 2016, astronomers were already aware of a difficult truth about planets orbiting red dwarf stars. They may exist inside the habitable zone and still be completely hostile to life. The reason is not distance. The reason is the star itself. Red dwarfs like Proxima Centauri behave very differently from stars like our Sun. They are smaller, cooler, and far dimmer, which means their habitable zones sit extremely close to the star. For Proxima B, that distance is only about 7 million kilometers. Earth, by comparison, orbits about 150 million kilometers from the Sun. So Proxima B lives roughly 20 times closer to its star than Earth does. That proximity changes everything. The closer a planet is to its star, the stronger the gravitational forces acting on it. Over time, those forces slow the planet's rotation until it becomes tidally locked. This means one side of the planet always faces the star. The other side never sees it. One hemisphere experiences endless daylight. The other is trapped in permanent night. If Proxima B is tidally locked, and most models say it almost certainly is, the climate would be extremely unusual. The day side could become intensely hot. The night side could plunge into freezing darkness. And between them would lie a narrow ring around the planet where temperatures might be moderate. Astronomers sometimes call this the terminator zone. If the planet has an atmosphere, winds could transport heat between the two hemispheres, possibly creating a stable environment in that narrow band. But this possibility depends entirely on whether an atmosphere still exists. And that question leads to the most troubling feature of Proxima Centauri. The star is incredibly violent. Red dwarfs are known for powerful stellar flares, sudden eruptions that release huge bursts of energy. But Proxima Centauri is particularly active. In 2019, astronomers recorded one of the most powerful flares ever observed from the star. For a brief moment, its brightness increased by nearly 14,000 times. The flare released enormous amounts of X-rays and ultraviolet radiation, blasting the surrounding space. For a planet orbiting as close as Proxima B, that kind of event is catastrophic. Radiation from stellar flares can strip atmospheres, break apart molecules, and sterilize planetary surfaces. And Proxima Centauri produces these flares frequently. Some occur every few days. Others, even larger, erupt periodically with far greater energy. Over millions or billions of years, this constant bombardment could erode a planet's atmosphere completely. Without atmospheric protection, the planet's surface would be exposed to intense radiation from its star. Liquid water could not survive long under those conditions, and the dream of a nearby Earth-like world would begin to fade. But radiation is not the only danger. Red dwarf stars also generate powerful stellar winds. These streams of charged particles flow outward from the star at high speed, interacting with any planet in their path. Earth is protected from the solar wind by its magnetic field, which deflects charged particles and shields our atmosphere. Without that magnetic shield, the solar wind would gradually strip away the gases that make our planet habitable. Mars offers a glimpse of what can happen when a planet loses its magnetic protection. Billions of years ago, Mars likely had a thicker atmosphere and flowing water. But once its magnetic field weakened, the solar wind began eroding the atmosphere. Today, Mars is cold, dry, and largely airless. If Proxima B lacks a strong magnetic field, its atmosphere may have suffered the same fate, only much faster. Because the stellar wind from Proxima Centauri may be hundreds of times stronger than the solar wind reaching Earth. Despite these dangers, some scientists still believe Proxima B could retain an atmosphere. Computer simulations show that if the planet formed with a very thick atmosphere, perhaps rich in carbon dioxide, it might still survive today. A dense atmosphere could redistribute heat across the planet, preventing the night side from freezing completely. Cloud layers might reflect radiation from the star. And oceans, if they exist, could help stabilize the climate. But this is where the newest observations from modern telescopes begin to complicate the picture. Because the more we study the Proxima Centauri system, the more unusual it appears. Astronomers have discovered evidence of multiple dust belts orbiting the star. These belts are similar to the asteroid belt and Kuiper belt in our own solar system, but their structure suggests a much more chaotic environment. Gravitational interactions within the system may be far stronger than expected. This raises the possibility that Proxima B experienced an intense history of impacts during its early formation. Frequent collisions with large asteroids or comets could have reshaped the planet's surface repeatedly. Each major impact has the potential to eject enormous amounts of atmosphere into space. Over time, such events could transform the planet completely. Instead of a calm ocean world, Proxima B might resemble something far more extreme. Some researchers now believe Proxima B could be a lava world. If tidal forces and stellar radiation heat the planet's interior strongly enough, volcanic activity could dominate the surface. Massive lava fields might cover entire regions of the planet. The day side, permanently facing the star, could become a vast molten landscape. Other models suggest the opposite extreme. If the atmosphere was stripped away early in the planet's history, Proxima B might be a cold, airless desert. Its night side could drop to temperatures far below freezing. Its day side would be blasted by radiation from the star. With no atmosphere to circulate heat, the difference between the two hemispheres could be dramatic. But there is still another possibility, one that scientists are only beginning to explore. Proxima B might be something we have never seen before. An alien world shaped by conditions completely different from those in our solar system. Planets around red dwarf stars may follow evolutionary paths that produce climates and environments unlike anything we are familiar with. Strange atmospheric chemistry, extreme weather patterns, oceans hidden beneath thick cloud layers, or surfaces altered by constant radiation storms. Because red dwarfs dominate our galaxy, this possibility carries enormous implications. If most habitable zone planets orbit red dwarfs, then the majority of potentially habitable worlds in the Milky Way might look nothing like Earth. They may be far stranger. And yet, Proxima B remains one of the most important targets in astronomy. Because despite all its mysteries, it is still the closest known Earth-sized planet outside our solar system. Future telescopes will study it more closely. Upcoming observatories like the Extremely Large Telescope, ELT, in Chile will attempt to analyze the light from the planet directly. By studying the planet's spectrum, scientists may eventually determine whether its atmosphere contains water vapor, carbon dioxide, methane, or other molecules. These clues could reveal whether the planet is barren, volcanic, ocean-covered, or something entirely unexpected. For now, Proxima B remains a puzzle, a nearby world that once looked promising, but now appears increasingly strange. And that strangeness may be telling us something important, because the universe rarely produces perfect copies of Earth. Instead, it produces worlds that challenge our assumptions about what planets can be. Worlds shaped by stars very different from our own. And Proxima B may be the first example of a nearby planet that forces us to rethink what habitable really means. Just 4 light-years away, a strange new world may already be waiting.